so welcome everyone. This is a joint venture between the Department of Physics and Astronomy. We have the public lectures that were started a few years back. We do about 2, sometimes 3 a year. And they are open to the community. They advertise quite broadly in all newspapers, etc. And the other part of this is that this is also an activity sponsored by the Institute for Cross-Disciplinary Engagement at Dartmouth, known as ICE. The good ICE, I always say, as opposed to the bad ICE, but the good ICE. And one of the things that we do is to have a fellows program, which is a little bit similar to the Montgomery Fellows program, if you're familiar with it, where we invite smart, distinguished, and usually fun people to be here for a while, to think and share some of their knowledge with the rest of the faculty and with the community in general. So one of the things fellows do is that they present a lecture, a public lecture about some of their work. And so today we're really, really happy that Adam Frank is going to talk about this brand new work. And in fact, you know, I was just in my office now checking my email, and I got an email from Astrobiology. Astrobiology is a scientific journal that publishes papers on astrobiology, meaning the study of life in the universe, and it says, highly cited papers, and yours was at the top.
Oh, wow.
So it just came out. So it's good to hear. I mean, literally, just happened 10 minutes ago. So that's good to hear. So Adam is a professor of astrophysics at the University of Rochester. He works with stellar formation and evolution. And when he's not doing that, or walking up the mountains in the area, he does a lot of work as a public intellectual interested in spreading science to the general public. So 7 years ago, we founded together the NPR blog called Science and Culture 13.7. It's been still going strong. And he's also the author of 2 books. One of them is called The Constant Fire. It's about moving beyond the science and religion debate, so to speak, or crisis, whatever. And the other one is about time. And the name of the book is About Time. So it's really about the perception of time from a cultural and scientific integrative narrative, I guess, right? And but he does that, but he also is interested in aliens. And he has a very interesting perspective in aliens, which has to do with what lessons can we learn in this planet if we look at other worlds and the possibility that these other worlds have intelligent civilizations out there. So Adam, please come in. And thanks for not going to Cornell West, by the way.
I'm sure that one will be streamed or whatever. You can, view that one later. Okay, so thank you very much, actually, for coming today and for showing up rather than going to Cornell West. Not that he's not awesome. Okay, so the title today is this is the nominal title of the book I'm working on right now about this subject. Our Fate in the Stars: How Our Universe, Rich in Alien Worlds, Can Help Us Save Our Own. And that's, as Marcelo said, this is exactly what I'm interested in, is the way in which the ways in which, if we broaden our perspective to think about what's happening to us, what I'm really interested in, I do a lot of writing about climate change and sustainability, and how broadening our thinking can change the way fundamentally we think about what's happening with climate change and sustainability. So this is sort of my premise. You can't understand a problem you can't solve a problem until you understand it, and you can't understand it until you can tell its story. And what I'm going to be taking you through today is a new way of telling the story about what's happening with climate change, this incredibly compelling, challenging problem, existential problem perhaps, in climate change. Now, there's a bunch of heroes in this story, which I'll not be able to sort of talk about. It's in the book, but I just wanted to mention them. There's people like Lynn Margulis and James Lovelock, who worked on Gaia theory, and then there's Jack James, who is just like, the greatest generation, an example of the greatest generation. He was in charge of the Mariner program, getting rockets to Venus when every rocket America was trying to launch was exploding on the launch pad. Verdanski, who was the guy who came up with the biosphere, and then of course Carl Sagan. I was amazed to come to see how much Carl Sagan played a role. We all know him as a public intellectual, but he was like, his fingerprints are on every development in this story I'm going to tell you, the science of the story I'm going to tell you. So it is a really amazing story that has been developed over the last 50 or 60 years, and it's a story that changes fundamentally the way we understand the problem, right? And what is that problem? The problem we know is climate change, right? We are anthropogenically driving changes in the Earth's climate state, and it's taking us from this nice, warm, moist state that we're in, which is great for civilization and agriculture, and we're sending it somewhere else, right? And the problem is, where else are we sending it, and what's going to happen because of that? And along with climate change, there's this general issue of resource depletion, right? Freshwater forests, biodiversity, we're pushing the planet pretty hard in ways. Now, sustainability, so what we think we need to do, right? So the problem is climate change. The solution is sustainability, right? And what is sustainability? Well, it's a scientific field that is the study of the interactions between natural and human systems, hopefully leading to new ways of, having a long-term version of this civilization, right? That will enhance human well-being. So, we're interested in sustainability. We think that's where we have to go. But the question is, do we really understand, how well do we understand sort of the link between the problem and what we think the solution is, right? Now, of course, you can't talk about this problem without talking about the politics. And what's amazing about the politics is to see how far it goes back. So the increase in carbon dioxide and its effects on the, the Earth's climate state go back, the recognition among politicians goes back to 1964. Right? So this is Lyndon Johnson addresses Congress in 1964 and says, this generation has altered the composition of the atmosphere on a global scale through radioactive materials, they were worried about nuclear tests, but also a steady increase in carbon dioxide from the burning of fossil fuels. So the idea that climate change is this new hoax that scientists are perpetrating on the world, this gives the lie to that. At the highest levels, people have known about it going back to 1964. And of course, all we have now is in the debate, in the public, is polarization and denial, right? We have, obviously now we have an administration that has literally called climate change a hoax perpetrated by the Chinese. So we've got this huge problem, and our ability to deal with it is incredibly limited because of how the politics plays out in this. So what is, my premise is there's a deeper problem. The fact the climate change and the denial is, and our general, we've known about it since 1964, and we just haven't really done anything about it. So it's been a failure of our political system. It's been a failure of the economic systems to try and recognize and deal with it. It's been a failure of our moral philosophy even to motivate us in some sense to be able to do anything. And for me, it's really a problem in perspective, right? Fundamentally, our problem is we think this is a one-time story. We look at climate change and the challenges it faces to civilization, and we're like, part of it is just like disbelief, like, oh my God, human beings, we can do this? We could change the whole planet? And I mean this seriously in that response because, because of the public work I do, I write a lot on climate change and I deal with a lot of climate denialists. Not just the hardcore denialists, but people who are kind of like, they're not taking a strong political position, but they're like, well, I heard this. Doesn't the climate change all the time? There's this sort of disbelief that even this thing could happen. And part of that is because we think it's the first time. We think that, human beings and this story that's happening to us has never happened before. So it's all a surprise. And I'm going to argue that we need to broaden the perspective. If we really want to understand what's happening to us, we need to broaden our perspective beyond just human beings and our moment in history. And part of this reason why is even if everybody agreed, even if everybody in the entire planet agreed that climate change was happening and we needed to do something about it, it's not even clear what we're supposed to do. We talk about sustainability, but as I'm going to show you, there's actually some significant questions about sustainability. So my premise is we need to learn to think like a planet. And we don't know how to think like a planet because this understanding of planets as a general phenomena, not just the Earth and our place on the Earth, but planets as a general, universal, cosmic phenomena is utterly new. It is something that has only been put into place over the last, at most, 4 decades or so. And it's just been this accelerating understanding of what planets are as sort of a phenomena. You know, there's plants, there's animals, there's planets, right? And planets have rules. That is what we've learned. And our place as a civilization in a planet will likely have rules. And we can know them, and that can help us understand what we need to do. So as part of this, I'd like to ask a question right now. I'm going to show you these 6 images of planets. Which one of these, can someone tell me, is the Earth? The lower, this one, right? All of them, there you go. So it was a trick question, I'm sorry. They're all the Earth. They are all the Earth at different stages in its evolution. You know, early on, the Earth had a magma ocean because when it was first forming, and then also the bombardments that it got, there were no, continents. The Earth didn't have continents. The Earth grew its continents. At best, early on, for a long period of its history, the Earth had, what were called cratons, sort of, size of India sort of thing. So it was a water world for a long time. And then there were times when the Earth had no glaciers on it, there were no poles, there was no ice on the planet at all. During the PETM, the temperature was average temperature was 7 degrees above what we have now. So it was a jungle world. There's been other times when the Earth has been completely, or at least maybe almost completely glaciated. So it was a snowball world. And in the future, the Earth will basically, as the sun heats up, the planet won't become habitable anymore and become a desert world. So they're all the Earth. And that is an important lesson for us to understand. There have been many Earths, there will be many Earths, okay? Because it raises exactly the question of where do we fit in with what we're doing right now? So the Earth has had many epochs. I love this diagram. You can see here, these are the different ages of the Earth. The geologists, talk about eons and epochs. So this is just a measure. You see time going back. This is 2.5 billion years. And you see all of these different ones. The ones we recognize are, of course, like Jurassic, et cetera. And here we are up here. So, we've had these different epochs, and they represent wildly different conditions on the Earth. And now, where are we now? We're in the Holocene. Okay, so the Holocene has been a long, not long by geological timescales, but long for us. It's been 10,000 years or so, period of warm, moist conditions that came after the last ice age, right? So all of human civilization was born and raised and flourished in the Holocene. Human civilization and the Holocene are tightly coupled, right? So, but the thing about the Holocene is the Holocene itself is just one of many interglacial periods, right? So this is a plot of temperature. So that's high temperature, that's low temperature, and ice volume, high ice volume and low volume. Going back, this is thousands of years, right? So what you see is here's us now, and we're in a period of, of relatively high temperature and low ice volume. But you can see, back here, there was cold temperatures and large ice volumes, et cetera. It's been oscillating back and forth. So the Holocene is an interglacial. We are in the middle of an interglacial. That's really important to understand because when we're worried about the climate, what we're worried about is the Holocene. Right? The Holocene is what we know. The Holocene is what is what civilization functions in very well. And it's not at all clear that how civilization would do in something that's not the Holocene. That is the problem, okay? So we don't want to lose the Holocene. So this question, this perspective, you look at this perspective of sort of the long history of just the Earth shows us the Earth has been many planets. And those planets have had significant changes. And now one of the things I want to turn to is what role has life played in those changes? So now I want to ask you this question. What would you experience if you landed on Earth 3 billion years ago? You had a time ship, you went back, and you end up in a place like this. Those are algae mats. So we're at a period when, there's a lot of life on the Earth. It's all single-celled, but, interesting things are happening. You get out of your time ship. Can someone tell me what would be the first thing that would happen? Exactly, right? That's great, yeah, you die. The first thing you'd experience was your own death. You'd be like, right? So welcome to the Earth. Welcome to the Earth 3 billion years ago, because 3 billion years ago there was no oxygen in the atmosphere. And the reason there was no oxygen in the atmosphere was that the plants hadn't created yet, or not the plants, the blue-green algae, right? So the oxygen that we're all breathing which fundamentally change the course of the planet's history is only there because of the activity of life, the large-scale activity, the large-scale success of one particular kind of life, the blue-green algae, the anaerobic, these are the oxic photosynthesizers. So they created the oxygen atmosphere wholesale, changed the course of the planet, particularly in what was called the Great Oxidation event. So the Great Oxidation, this is a plot of oxygen versus time. So this is oxygen levels in log scale versus time. And what you see is early on, this is 4 billion years ago, the Earth had an atmosphere. It was mostly carbon dioxide and nitrogen, but it had about 1 million times less oxygen than the atmosphere we breathe today, which is why if you landed there, and tried to breathe, you'd die. But then somewhere around 2.5 billion years ago or so, the oxygen in the atmosphere increased dramatically. Now, exactly what was going on here, geologists, there's details that geologists are still working out, but it is generally accepted, universally accepted that where the oxygen was coming from, its source, was life, right? So this demonstrates something that's really important, I think, in our discussions and our perspective, and it's the idea of coevolution. So when I talk about people not having, not getting the idea, or sorry, having a difficult time with the idea that we've changed the planet's atmosphere, right? That the CO2 that we're dumping into the atmosphere via fossil fuels could actually have an effect. I'll often see people talking about, like, well, CO2 is a small amount. It can't really have an effect. Life couldn't do that. We're not that important. Well, actually, this is just another example. What's happening with us is just another example of coevolution. The planet and life are closely connected. So the planet has been evolving with the life that it has. So you can't sort of separate them out. The biosphere is, as we're going to see, has been a pretty important player in the evolution of the Earth. And by the Earth, what we're really talking about is the surface layers, right? From the lithosphere to the atmosphere. Obviously, the core of the planet doesn't really care that much. Though things that happen in the core, a la the magnetic generation of the magnetic field, do matter. But this idea of coevolution is that the life and the Earth, and by the Earth we mean the coupled planetary systems of atmosphere and ice and oceans, have been evolving together for a long time. And in general, people don't know this. People don't understand this, right? That life and planets can, at least for the Earth, as we've seen, go together very, very tightly. So part of this recognition was embodied in something called the Gaia Hypothesis. So it was Lynn Margulis and James Lovelock. It's really a fascinating story of how this came about. The Gaia Hypothesis was the idea that the planet as a whole, that life as a whole was regulating the conditions on the planet to keep them favorable for life, right? So if I dropped you down in the desert, right, you'd start to sweat, and you'd start to sweat because evaporation would, start to cool your body and keep your temperature at a nice 96 degrees Fahrenheit or so. And so the Gaia hypothesis was, you know what? Life actually plays a similar role. Life has feedbacks that keep the planet in a stable place in terms of its conditions relative, to life, keeping the planet. So the planet has sort of a thermostat. And what's interesting about this idea came about by James Lovelock, who was asked to come to NASA in 1961 to do, they were trying to figure out experiments to do for looking for life on Mars. And he was listening to people talk about, we got to look for microbes, and we'll do experiments to look for microbes. And he was like, how do you know what the microbes are going to look like on Mars? You can't just assume they're going to look like on Earth. And it dawned on him that you could look at the atmosphere, right? Just like I told you, the Earth's atmosphere, if there wasn't life, the oxygen would be gone very quickly, right? So the atmosphere itself, if you looked at the atmosphere from a long way, you could, in some sense, tell that there was life on Earth by the presence of oxygen. Okay? So he said, look, we should look at life itself. We should look at the presence of life itself in terms of the atmosphere. And then it was so he started working on these sort of atmosphere as life detector experiments. And it was a few years later when he was literally sitting in an office with Carl Sagan. Like, Carl Sagan wasn't talking to him. Carl Sagan was just like working on his own stuff. But this is Carl Sagan again appearing in this story in totally weird ways. When Lovelock was looking at pictures of Mars, and they just had discovered they really understood how much CO2 how much carbon dioxide was in the Martian atmosphere, that the idea of Gaia, that the idea that the Earth has been life on the Earth has been regulating the atmosphere to keep life comfortable, dawned on him. So, and then it was, and again, Carl Sagan is going to make this other weird appearance because, a few years later, Lynn Margulis, who was a biologist who had been Carl Sagan's first wife, she was working on this idea as well from, let me turn this off. She was working on this idea as well from a perspective, from a microbial perspective. She was looking at how microbes can, just like the blue-green algae, how they can change the atmospheric composition. And she asked Carl Sagan, hey, I need an atmospheric physicist. Who should I talk to? And he said, oh, yeah, this guy who was in my office, a couple years back. So Lovelock and Margulis got together because Margulis was married to Sagan, blah, blah, blah. So it's just an interesting story how Carl Sagan just keeps popping up on this story. So the Gaia hypothesis was really important and super controversial. And one of the reasons it was super controversial was because of these two guys. Oberon and Morning Glory Zell Ravenheart, right? So they look like a very groovy couple, don't they? And Gaia, of course, what made scientists so angry about Gaia was the fact that people like this loved Gaia. So they are actually, I've read a story about the two of them. They are Gaian priests and priestesses, right? And so the thing with Gaia is, the public loved Gaia. It was a beautiful idea, the Earth Mother, the planet's alive, it's a big cell. One giant cell. And so, scientists really pushed back against this teleological idea of that the Earth had some kind of consciousness and it knew how to regulate itself. So, this idea of Gaia went back and forth for a long time. But eventually, people came to understand there was a part of it that was very important, and that was what we now call, we don't use the word Gaia anymore. We talk about Earth system science. Because the problem with Gaia was that it was teleological. Or at least the strong guy, was that Earth had some intention. Like, the Earth wanted the Earth to be, comfortable for life. And that just, raised hackles on for scientists. But if you get rid of the teleology part, you can still recognize that the biosphere is a primary player in the history of the planet. So there's these coupled systems. You've got the cryosphere, which is the ice. You've got the lithosphere, which is happening, which is the ground, the rock, volcanism, weathering, etc. You've got the biosphere, the atmosphere, and the hydrosphere, and you just can't separate them. You can't pull them apart. All together, they constitute what drives the Earth's evolution. Now, it's into that context that we now can place the Anthropocene. Can I just ask by a show of hands, how many people have heard the term Anthropocene before? Okay, so lots have, but lots haven't. So the Anthropocene is an really powerful and interesting idea. First came around more than 10 years ago, and it was sort of a recognition that, if you were to come back, 1,000 years from now or 100,000 years from now, and you looked at the stratigraphy, I have a hard time pronouncing that. If you looked at the layers of the Earth, you would probably see a layer that indicated our presence, that we have, that we're actually leaving enough deposits of our activity that you'd see our presence, and that we are. So this is representing a new geological epoch, right? There's the Holocene, and now what's happening with climate change, with all the other things we're doing, we're entering the Anthropocene. Okay, so it's the human-dominated geological epoch. Now, there's still a lot of arguments about when the Anthropocene started and whether or not there already you could see stratigraphy in the layers, whether or not you'd see our presence yet. But now it's become to be more general, which is just the recognition that whenever that layer shows up is less important than the fact that right now humanity dominates the action of the planet, what's going on the planet. We move more mass around than all other features or all other processes. The critical elements like it's phosphorus, that we're moving more of that around than any other process. So there's just a number of things, and then of course there's climate change. There's just a number of different processes that are critical to the Earth, functioning of the Earth, that really, it's human beings that are driving. So the idea is that we're now entering a new epoch. A new geological epoch, the Anthropocene, and it's going to end up being a different kind of planet. It's going to be a planet that has a different climate state and may have, different circulation patterns, etc. So our entry into the Anthropocene, right? It raises all kinds of fundamental questions for us. that I want to explore for a little bit. So the entry into the Anthropocene raises questions, new questions, about the nature of human activity within these coupled systems, right? So, we introduced the idea that there are, the Earth really should be seen as these coupled systems of ocean, atmosphere, and life. And now here we are, one form of life. What's our role in this? What does the Anthropocene tell us about this? So the first thing I want to point out, which some people get angry about, but I want to say that when we talk about the Anthropocene and climate change, et cetera, we're not talking about saving the Earth, right? The Earth will be just fine. That's the point of showing you all those pictures, right? The Earth is, the Anthropocene, the story of the Anthropocene may be the Earth just moving on without us, right? So for example, we're very concerned, as we should be, about the mass extinctions, but if you look at the history of the Earth, you're here because of a mass extinction, right? The mass extinctions for the Earth has just meant, you've wiped out a bunch of niches, and now new niches can be filled. So, this is an example of an early mammal that was, sort of like cowering at the feet of the dinosaurs. And once you got rid of the dinosaurs, you could enter the age of the mammal. So there's one way of looking at it that, okay, we're driving a mass extinction event. Does the Earth really care? It'll just fill up the empty niches. Okay? So, so when we talk about sustainability, what exactly are we talking about, right? And this is where I think some really profound issues get raised. What are the moral imperatives of the answer to this question, right? So for example, right, this is our archetype of sustainability, and we think about, and that whole idea of saving the Earth, right? It's the polar bear on a lonely iceberg that is slowly melting away. And I think it's always funny about this because polar bears are amazing hunters, and also they're unlike black bears, which you guys deal with, they will just run out and kill you and feed on your entrails because there's not a whole lot of stuff out there. So but we love polar bears because they're cute and they're adorable, and we really are concerned about, oh my God, it would be terrible if they went extinct. But what about this guy, right? We're not really ever, bumming out about the velociraptors, like, oh, it was such a bummer that we lost the velociraptors. They were so cute. And oh, no, right? But in some sense, when we take this sort of long perspective, why is the polar bear more valuable than the velociraptor, right? So that's the question that gets raised when we ask about sustainability. So I think part of the new perspective we're coming to understand, and the responsibility it puts on us, is to understand what exactly are we trying to sustain. And what we're trying to sustain is a particular kind of civilization, right? We want a civilization that's technological, right? We don't want to go back to ancient Rome. We want a civilization that's energy intensive, right? That allows us to do all the things that we get to do, like coming to lectures and using computers and doing interesting things. And we want a relatively high population, right? Clearly we have issues with population, but we don't want to go back to 100,000 human beings, right? It's not clear that you could have the first two with a very low population, right? To maintain a high technology, high energy, or energy intensive civilization, you need enough people to have the networks that make that work, to populate them and to do the work to make them functioning. And then finally, of course, we want all of this with maximum human well-being. That's what we mean by sustainability. And what does that mean? It means that we have to hold the Holocene, right? We're going to say, like, okay, from now on, Earth, those planets I showed you, not anymore. As long as we're around, it's the Holocene, right? Because the Holocene is what we know. That's the one with polar bears in it. And it's the one that actually works best for us, right? And that raises all kinds of issues, right? What does it mean to say, because really, actually, some people would argue we're overdue for an ice age, right? That the interglacial, we're kind of at the end of the interglacial. But as long as we're around, we're not going to let the glaciers, the next ice age happen, right? That's our activity is raising the temperature of the planet, so you're not going to get another ice age, unless, of course, there are ways in which the coupling could trigger that, but let's not go down that road. Either way, the important thing is we're trying to hold the conditions we grew up in, right? That's what we mean by sustainability, and that has a lot of issues with it. So, but by sustaining the Holocene in perpetuity, are we taking on the role of planetary stewards in some sense? Like, what are we in this history of the long history of the Earth's evolution? So what does that make us? Where do we fit into nature now? And really, this is the question, what is nature anymore? On a planet where, the intelligent, an energy-intensive technological species is holding the planet in a particular kind of state, what is nature anymore? Right? How do you define nature? Because the effect of that civilization now reaches across the entire planet and its evolution. So this is where So now we're going to shift. This is where the astrobiological perspective really comes into play. This is what I want to talk to you about how the astrobiological perspective can both shift the way we talk about things and ask some pretty compelling questions. So astrobiology is essentially the study of life in the universe. People have been thinking about this for a long time, but it's really only over the last, you could say, 30 years, 40 years, that things have really accelerated. Our understanding of this problem, or of this field, has just exploded, in particular because of these three revolutions. Now, there are those who will say astrobiology, well, how can you have a field that only has one thing to study, right? That's a reasonable question, right? We only really know of one form of one kind of life in the universe, ours or the stuff on Earth. But that, if you're going to take that perspective, you're going to miss all the ways in which this field has been able to ask compelling questions and be able to actually see a lot about the background in which life will form or could form. So these three revolutions are: one, the discovery of exoplanets. So we're going to walk through these all in more detail. Two, the exploration in situ, meaning sending little boxes of electronics or robots to other planets. And then the exploration of Earth's own past. So let's walk through these in a little bit more detail. So first is the revolution in exoplanets. So you can go back to the Greeks 3,000 years ago and read their stuff and find they were asking the question of whether or not there are any other planets around any other stars. That question, what they call the plurality of worlds, has been with humanity as long as humanity has existed, and you get to live in the generation where it's answered, right? How often does a 3 millennia old question actually get answered, right? So we now know that every star in the sky, every star you look at, has planets orbiting around it. And we also know that if you count up 5 of them, one of them is going to have a planet in just the right place where liquid water can exist on its surface. So you can get rain, you can get oceans, you can get rivers. And because we think that life is so important, or water is so important to life, that's a planet where life could actually form. So the exoplanet revolution has just completely changed the game in understanding life on other planets. Revolution number 2 is solar system studies. So for example, here is a great picture. This picture could be Tunisia. It could be a desert in the southwest, but it's Mars, right? So Mars is now the only planet that we know of that is entirely inhabited by robots, right? So there's like at least a few. I'm not sure how many are actually still working, but I think there's at least 2 or 3 robots rolling around on Mars very slowly, doing explorations. And it's hard to understate how important this is. We have been sending, that's why this guy Jack James I talked to you about, the guy who was like, in 1961 when every rocket America was trying to send up was blowing up, and he was given this task of like, get us to Venus in 8 months. And it was just, it's a really great sort of story of that, back in the era of American can-do. It's like, yep, we got to get a rocket to Venus, we're going to do it. And they did it. They did this amazing thing of managing to get this first probe. We were obviously in competition with the Russians then, but get a probe to Venus. And since then, the Americans, the Russians, the Europeans, the Indians, everybody's been sending probes to the solar system objects such that we've now visited every kind of object in the solar system that exists. Okay? We've visited all of the planets, and we visited asteroids, we visited comets, we visited dwarf planets. So, we now have, and some of the, in a bunch of objects, we've actually sent things to roll around on the surface. So this has completely changed our understanding of planets, as you can imagine. Because what it means is these in situ studies of other planets have shown us about climate change as a generic feature, right? It's shown us that climate, we know what the climate on Mars is like. We can predict, we have models for the climate on Mars that work really well. We have models for the climate of Venus that work really well. So if you're talking to some climate denier and they're like, oh, the models, they're just models. It's like, well, they work on Mars, right? They work on Venus, they work for Titan. These models aren't just pulled out of, out of a box. They've been decades of studying other planets, having more than one planet to test this idea of climate and climate change on to work with. So it's Venus that taught us about the greenhouse effect. It's Mars that taught us about dust, right? So how many people remember the whole debate about nuclear winter, right? So nuclear winter was a huge part of the 1980s and the Reagan era, and those studies were directly informed by Martian dust storms. Like they literally took what they'd learned from having stuff on Mars and the huge dust storms you get on Mars, and they put it into their models of nuclear winter, completely affected the debate on nuclear proliferation back then. So it's other planets that have taught us about our planet in ways that make our current understanding of climate, we would not have our current understanding of climate without them. They also show us, because we look at Mars, for example. So here's a picture of what Mars might have looked like 3.5 billion years ago. Mars was once an ocean world, maybe briefly, but we're still trying to figure that out. But it's clear, we have absolute evidence that there was water, torrents of water running on the surface of Mars, right? But now it's a dry desert world. So it shows us that habitability, right, the possibility for a planet to be habitable is a moving target. Likewise, sustainability is going to be a moving target, because sustainability is really just a subset of the questions of planetary habitability, right? Sustainability is you want your planet to be sustainable for a particular kind of life, ours, right? A particular kind of civilization, ours. So, we've learned from studying other planets this broad way of thinking about our own existence. And the revolution, I've already talked a lot about this, so I don't need to go into it. The history, the Earth studies, that we now have a very high resolution understanding of the Earth's history going back 4.5 billion years. So all three of these revolutions have changed our understanding of planets. And they've allowed us now to begin thinking like a planet, right? So when I talk about the Mars climate models, that's what I mean about thinking like a planet. We know the rules of climate deeply for all planets. Our understanding of climate is good for any planet that's got an atmosphere, okay? All right, so what that means is we have to think, what does astrobiology change? It means we must think about the Anthropocene in a broader context, right? And that leads to this question, this all-important question, right? We think about sustainability, we gotta have sustainability. How do we reach sustainability? How do we know sustainability is even possible, right? How do we know that, like, anywhere in the universe, that any civilization that has ever formed across these 13.7 billion years of cosmic history has ever achieved sustainability? How do we know it's something that the universe does, right? So that is a question I now want to address for a few minutes. Because, right, this is obviously very important to us, because if it never happens, then it means we're doomed, right? Now, I'm going to tell you right now, that's not what I think is going to happen, but we have to frame the question. If we're going to understand where we're headed and how we should head there, we have to understand what the options are, right? So by broadening our view to this cosmic view, we can ask this kind of question. So in order to do that, now the aliens come in. Right? So we've been waiting, like, when is he going to talk about aliens? He promised me he was going to talk about aliens. Now I'm going to talk about aliens, right? But I'm not going to call them aliens, I'm going to call them exo-civilizations, right? Just like I talk about planets orbiting other stars as exoplanets, I want to think of aliens, I want to think of other civilizations as just another example of this phenomena of a species becoming intelligent, learning how to harvest energy, and building some sort of information resource processing system that you want to call a civilization, right? So we don't have to get into the details. The whole point is we're not going to ask anything about the sociological details of these civilizations. We're not going to ask whether they're warlike, whether what kind of economics they have. We just want to ask about these civilizations as something that interacts with their planets, right? Because that's what we're interested for ourselves. We've been interacting with the planet, we've driven the Anthropocene, what happens next, right? So my contention is that if we do this for the exo-civilizations, we can now take ourselves out of being a one-time story. We're just another example of this process that has happened again and again and again on planets across cosmic history and time. But of course, how do I know this has happened, right? Maybe we're the only time in cosmic history this has ever happened. So if that's the case, then kind of my whole argument falls apart. So now let's spend a couple of minutes about why we're not the first. Okay, so the whole history of thinking about aliens is a battle between optimists and pessimists, right? Optimists are like, yeah, it happens all the time. Pessimists are like, no, we're completely unique, right? And the way scientists have come to think about this problem is through what's called the Drake equation, right? So the Drake equation is this famous formulation of the problem. It's really not an equation more than it's not a law of nature, it's a statement about our ignorance. And it just basically says that the number of civilizations right now in the galaxy that we can interact with is equal to the product of a bunch of different factors, okay? And in particular, there's the rate of, there won't be a test, but there's the rate of star formation, the fraction of planets that exist around each star, the number of planets in the right place for life to form, the fraction of those planets where life actually does form, the fraction of those planets where intelligence is created, and the fraction of those intelligences that go on to create technology. And then finally, there's the lifetime, the average lifetime of the species, okay, of the intelligent species. So Risa, the paper that Marcelo was mentioning was a paper I wrote with Woody Sullivan. And basically what we said is, look, there's this exoplanet revolution just happened. We ought to be able to do something interesting with all that data that's relevant to the question we want to ask. This question I want to ask about other civilizations. So what we were able to do, we were able to use that, that data to set what we called the pessimism line. So here's the question we wanted to ask. What is the probability for intelligence, an intelligent civilization to form on a planet have to be in order for us to be the only time it's ever happened in the galaxy? How bad do the odds have to be for us to be the only time this has happened? And the answer is 10 to the minus 22. So that is 1 in 10 billion trillion, okay? So this is what this means, right? We don't really know what nature actually does. We don't know what nature, I give you a planet that is in the right place for life to form, what are the odds that it's actually going to happen there? What this number tells you is as long as that probability that nature chose is bigger than 1 in 10 billion trillion, then we're not the first time it's happened, okay? Does everybody get that? Because this is just such a critical point, right? So 1 in 10 billion trillion is pretty low odds, right? It's pretty crap, that's a small number. So as long as nature is a little bit better than that, as long as nature's processes are a little bit better than that, then there have been other civilizations in cosmic history. Doesn't mean they're around now, right? Because we're not talking about lifetimes here. I don't know how long they last. It just means that they've formed. To me, this is a stunning kind of conclusion. And if you want to see sort of how this fits into history, if you look at famous pessimists, people are like, no way, there's no way that civilizations form. You go back and you actually look at the numbers that they gave, right? So there's the famous Ernest Mayr, who argued with Carl Sagan about this. He said 10 to the minus 15. Brandon Carter said 10 to the minus 20. Brandon Carter, in particular, when he came up with this number, he said this value, 10 to the minus 20, is more than sufficient to ensure that our stage of development is unique in the visible universe. But this is actually 100 times bigger than the value that Woody and I came up with, right? So that means that if Carter, who's an absolute pessimist, were right, it would have happened 100 times. There would have been 100 other histories of a civilization, a species waking up to itself and becoming technological that would have played out across history. So the idea here is that because the pessimism line, as we call it, is so low, nature has to be really biased against the evolution of civilizations for what's going on with us to not have happened thousands, millions, billions, trillions of times. There's been, perhaps it's reasonable to say that this has happened trillions of times, trillions of histories like our own. Where did they lead, right? And that's what takes us back now to the Anthropocene. Because if you accept the idea of the pessimism line, then it means that there have been civilizations before, evolving on planets before, and the argument I'm going to make now, and I probably don't have the time to go through this in detail, is they've all driven an Anthropocene. The Anthropocene, when we talk about the Anthropocene as being the civilization pushing back on its planet, driving its planet into a new state, our argument is that it's almost impossible to get away from, right? So the question is not, are we driving climate change? It's, of course we're driving climate change. What did you expect, right? A civilization is fundamentally, by definition, a mechanism by which energy is harvested from a planet in whichever form, and there's only so many forms, by the way. Energy is harvested off of the planet, and then it's used to do work. Build buildings, organize, move stuff from one place to another, however you want to define it. And that the second law of thermodynamics tells us you can't do that. You can't use that energy and not create waste, right? This is the reason why you can't have a perpetual motion machine. It's why things always break down, right? If you use energy to do something useful, you also create crap, right? And so what this means on a planetary scale is that there's always a feedback. There's always a pushback. Even wind. If we were to power this entire civilization with wind, we'd still end up with 2 degrees of warming. because you're extracting energy out of the climate system in terms of laminar flows, smooth flows of wind, and you're using it to turn wind turbines. So there's no free lunch. Nobody gets a free lunch. And so what this means for us is that the Anthropocene has happened before, and because we know enough about planets and how they respond to forcing, to waste being dumped into their systems, we can model the feedback between any civilization and its planet. And we can try and make general global predictions about what those histories will look like. So in the interest of time, I'm going to skip through this section about what that would look like. Right? So here's just an example of what a model for a civilization might look like in terms of, so this is like population and energy consumption and planetary forcing. And what we can imagine, by planetary forcing I mean how much you're pushing back on your planet. And what we can imagine is that there's different kinds of trajectories for any civilization, and some are going to lead to collapse. Here's a collapse one, where the civilization grows, it uses more energy, it becomes more technological, it has higher birth rates, and then it pushes its planets too hard until the planet can't support it anymore. You end up with some kind of instability, and it collapses. Right? The civilizations, the numbers just collapse on themselves. As opposed to a sustainability trajectory, where your numbers grow, you push back on the planet, but you recognize what you're doing, and you shift over to some kind of new energy modality, and you end up with some kind of stable population, stable amount of energy available to you, and you end up with a sustainable form of the civilization. So the question is, which one of these trajectories are we on? Which one of these trajectories is the average, right? So if I had 1 trillion civilizations and I knew their histories, right? Or if I could model their histories theoretically, what would most of the trajectories look like? Because that's the thing that we're interested in this project. Actually here, if you want to know what human beings look like on a plot like that, so here is population, here's energy, and here's CO2, which is like how far we're pushing the climate. And you can see, look exactly what we're doing. Our population is skyrocketing, right? We're increasing the amount of energy per capita we have available to us, and we're pushing on the planet. So the question is, which trajectory, where does it go from here? Okay. So let me just get to, so what we're interested in doing this perspective allows us to do this kind of science where we do these models. Obviously we don't have data, but we can do the models because we understand the physics quite well. We can go out and figure out what is, at least theoretically, the average lifetime of a civilization like ours. And what will we get when we do it? We haven't done this yet. We're just starting the project. But you can imagine if we find out that in our models, the average lifetime is 200 years, what does that mean? It means we're in trouble, right? It means that, in general, nobody makes it more than a couple of centuries, right? And so that means it's going to be very difficult. You're going to have to be very careful about your choices as you try to sail through the bottleneck of the Anthropocene, or the version, whatever version of the Anthropocene you have on your planet. But if the average lifetime is 2 million years, then there's a lot of wiggle room. It means that you can make a lot of mistakes and you'll still sort of recover. So this perspective, by broadening the perspective, we get to understand what's happening to us as a generic kind of thing that occurs in the universe. So now just to conclude in the last 5 minutes, I want to talk a little bit more about the sort of the ethical implications of this. As well as this story, right? I said, you can't understand a problem, you can't solve a problem until you understand it. That's what I've been talking about. We have to understand the problem is we are just another civilization, another thing the Earth has done, but you also have to have the story. So now I want to talk a little bit more about the story as a whole, about what we are and who we are and what our place is on the planet and the planet's place in the cosmos. So what we are is just an energy harvesting species, right? And energy harvesting species and their civilizations, that's just something that planets do, right? It's just like, planets create, there's blue-green algae, there's dinosaurs. Civilizations are just another thing. We're not that unique and we're not that special from this perspective, right? And so it puts us back into the biosphere as part of the biosphere, not above the biosphere, right? Every one of these civilizations that occurs is just an experiment that's being run by the universe, and there's been lots of these experiments been done. That's what the pessimism line shows. Most likely, this experiment has been run many, many times before. So human beings in our civilization, we're not different from nature, right? You can't separate out us and say there's nature, which is what you do when you go in the woods, and then there's us. New York City is nature. New York City is nature as much as a dinosaur nest is nature. Okay, so this is about reintegrating ourselves back into the history of the Earth, not seeing ourselves as special, not seeing ourselves as somehow unique and that we were given this planet for our own benefit. We're an expression of what planets can do, right? We're an expression of this particular planet, and from this broad perspective, civilizations are expressions of what planets can do. So we're an experiment, basically. And there's lots of experiments. And from this perspective, what it shows is that the Anthropocene is really, the question with the Anthropocene is just whether or not the Earth moves on to another experiment, or whether we kind of figure out how to kind of cooperate with the planet to keep this experiment going, right? Because the Earth, as the history shows, will be happy to just move on and start doing something else. So, and this actually, here's the ethical. So some people will get very angry about this to me, but I think it's really important for the narrative we tell, right? Because you got to go out and talk to people and frame a story for people who are not necessarily on your page about climate change, right? And it's this: climate change is not our fault. Now let me be clear about what I mean by this. It was a mistake in some sense, driven by the adoption of a particular mode of energy harvesting. We stumbled across coal, we stumbled across oil. It turned out to be amazingly awesome for doing the things we were doing anyway, which was building stuff, right? Building civilization. And so we used it, right? It wasn't like the first guy found oil and was like, I will destroy the world with this, right? So that part, triggering climate change, is not our fault. It's not something we did intentionally to be jerks, right? But what will be our fault is if we don't do something about it, right? We now know about it, and the question is, what do we do? So this means changing the whole narrative, right? And this is really important, right? The Anthropocene is not a story of human greed, right? Triggering the Anthropocene is not a story of human greed. It's the story of the planet doing what it does. One of the things it does is, evolving a civilization. It's not a story of inherent human unworthiness, right? It's not a story, you hear this all the time, human beings are a plague, we're a virus on the planet. It's like, no, we're just another thing it's done, right? So this human hating is just like, it's completely unproductive. It's wrong, and it's completely unproductive. Because, if you got to go out and tell people a story, and this is about stories on a mythic scale. Human beings don't do things because of reason, right? En masse. We do things because there's a mythic scale narrative that motivates us. This is about value. This is about what we see as being important, right? So, scientists, we value reason. We should value reason. But when you get to this larger scales, we need a narrative of our place in the universe in order to really be motivated. So the Anthropocene is fundamentally a story about a planet and its experiments, okay? So this brings us back to the final factor L, because everything is about the collapse, whether or not the thing we don't want is to have, the civilization that we now have collapse. So I won't go into this in too much detail. So I consider this to be, the right way to think about the Anthropocene is the end of our childhood, right? This is the, so there's the famous book by Arthur C. Clarke, Childhood's End. So the true lessons of the Anthropocene is planets have rules, and we've got to learn them, right? We've got to integrate ourselves back into the rules of the biosphere. We sort of thought that, like, we can do whatever we want. We are powerful, we'll just march. You look at the science fiction from the 1960s, right? And it was about, we just have to marshal enough energy and we'll do whatever we want. The lesson is like, no, that's not going to work at all, right? The biosphere is way stronger than you are, and it'll just, it's just going to go on and go somewhere else. So you've got to, like, sort of understand what the rules of planets are and work with them. That's what I mean by thinking like a planet. Sustainability, in some sense, is what sustainability will be an awakened version of a planet, right? It's going to be the intelligent species working with the biosphere in a way that both flourish, okay? So this actually requires, I think there's some really interesting stuff in this, it's the adoption of deep ecological values, where compassion and identification with all life is a primary value. We've been putting ourselves up here like, we can do whatever we want. A lot of our religious myths have that, and it's like, no, you can't. You are part of this thing called the Earth and its movements. So I like to think of ourselves, we are like cosmic teenagers, right? So because again, this idea that, I will strongly argue that this has happened lots and lots of times. Unless the universe is strongly biased against civilizations, this has happened trillions of times, right? And just like, the maturing of a human being, at some point, you're 17 and you get the keys to the car, right? And you're probably an idiot, because most of us were at 17. And the question is, are you going to make it? Are you going to be able to make it to the next phase? And most of us sort of learn how to do it. And we are like cosmic teenagers just at that moment where we're going to see whether or not we can make the transition. Now, the important thing for me, this also on the philosophical level, is that it's the completion of Gaia. And I'll just finish up just one or two more slides, and I'll be done. Gaia, remember, people pushed back against Gaia because of the Ravenhearts and that whole idea, that sort of groovy idea that the Earth wants something. But this actually allows us to see that there is a completion of Gaia. There is a teleology, and it's the civilization. Yes, intention can eventually make it into Gaia because a civilization comes and starts to work with the biosphere and has a goal, which is to maintain the planet in a state that is healthy for everybody. So this brings me finally to the idea of the nosphere. This is Teilhard de Chardin came up with this idea that there was this, there's the geosphere and the biosphere, and eventually there would be the noosphere, which was, for him, because he was kind of a Catholic mystic, it was the idea that there would be the planets would eventually create like a sphere of intelligence and souls, around it, that the planet would be circled by, intelligence. And it's a cool idea, but it's a little woo, for a guy like me. So lots of people liked it, if you're woo enough. But for science, it's just very hard to know what to do with it. But then here's the interesting thing about the noosphere. We just ended up building one, right? Like whether you believe in souls or not, I don't know. But we just ended up creating a noosphere, which is the internet, right? The planet is now encircled by intelligence, right? Right now in this room, we are all, there's waves of information via our cell phones passing through us. So on some level, maybe this is the next step. Because in order to come to some kind of cooperative arrangement with your planet, it's going to require some kind of global interaction with the planet and the civilization such that you come to a sustainable state. So maybe these noospheres are, in fact, actually the next logical step in the development of a sustainable civilization. All right, so I'm just going to go. So yeah, I want to say I don't want anybody to come away from this talk thinking like I'm saying like, oh, it's inevitable climate change. It's inevitable that we fail. Climate change is inevitable. I think for any civilization you're going to drive civilization, but that we fail, that's the open question. What we require now is a global view, a planetary view, and we have to have hope and we have to have optimism. And the reason why that is because in the proper context, the Anthropocene is not a story with villains. It's really just a story about winners and losers, and we just want to make sure that we're on the winning side, right? That we win in terms of entering the, sort of the civilizations, the community of civilizations that have made it through to the other side. So, I'm going to argue for sure someone else has made it, so why can't we, right? So I'm going to end with this vision of optimism, hope. This was a talk that Bill Nye gave at my university, and the room was packed with these kids. I was just amazing, and they were pumped, and they were, he's talking about nothing about dealing with climate change and the engineering we're going to do and all the work we're going to do, and these kids were like, they were coming out of their seats. So I was just like, there's absolutely hope. So I'll end there. I thank you for enduring this, and I'm happy to take questions.
Okay, so the way this works is because we are videotaping this. Anybody that wants to ask a question, I hope you do, because this was an amazing talk. We'll have to do it through the microphone, okay? Are you capturing this, Sarah? Yeah, okay. So questions from the audience? Anyone? Okay.
So it would seem that when evolution gives us a creature like ourselves or something similar on another planet, there's going to be a range of intelligences and consciousnesses, and those that are at the bottom of that are probably less likely to make it. And I wonder what your thoughts are about that.
Yeah, that's an interesting idea. So the way I've tried to, right now, the way I'm trying to do the models is to actually remove everything except sort of the physics and chemistry of this process, and just try and have like the choices be just input numbers in some sense, to not go into. But yeah, so you can really ask though, what would it require in order to make this sort of global decision? Oh, we're all going to switch to a low impact energy source. And it may be that evolution has bequeathed you certain kinds of sociability, right? That maybe about the network structure of your intelligence, right? How deeply social are you? A hive mind, right? Like, so termites have a very different kind of social structure than we do. So maybe only hive minds make it, or maybe hive minds can't make it. Maybe you need some degree of individual, separate sort of consciousness. Right now I don't have any thoughts about that, but I think eventually that would be like through network theory or something. I think you might actually be able to look at that. Because it's kind of like a phase change you need to go through. Like your civilization's doing one thing, and you need the whole civilization, to sort of move to this new state, and that is like a phase change in a solid or something.
So in your models, and one of the assumptions is about sort of like Earth or planet as the unit,
yeah.
Right? But you also looked at L being from 200 or optimistically 2 million or something like that, right? So from that perspective, my guess would be like, that why not treat sort of like the unit as the planetary system rather than just a planet or solar system? Meaning to say that, because then you are not limited to resources on a planet,
right.
But rather it adds up other resources, and that can dramatically change what would happen, because you are looking at a longer time frame for
right.
intelligent civilizations.
Yeah, no, that's a really good point. But so since what I'm really trying to avoid is sort of, I want to keep it as much to physics and chemistry as possible, because trying to do alien sociology is really difficult, right? Who knows what they're like, and then you end up writing science fiction stories. So what I really need to focus on in order to do that is young civilizations like our own that are just climbing up the learning curve, right? Because technology is always a ladder, right? You're not going to invent nuclear power until you've invented alloys, until you know how to make alloys. You're not going to be able to build a wind turbine blade until you've had simpler, kinds of metals, etc. So what that means is I can't ask myself about future technologies, right? Because then who knows? Like, in 2 million years, where we're going to evolve to technologies. So I kind of really need to stick to, in order to do this initial phase of an Anthropocene. When you're a young civilization, you probably don't have interplanetary travel is pretty hard. So you don't have that yet. You're still, you're just kind of, so I can only, I think, with my method, stick to young civilizations that are still single planetary. So that's my argument for that. Maybe there's other ways of doing it, but in order to try and keep the science fiction stories out, I feel like I need to do that. But your point is a very good one, that because once you get multiplanetary, then very different things can happen.
Hi, I have a question that may or may not pertain directly to what you've been discussing. A few years ago on one of the NPR stations, it's my understanding we have a universe and it's infinite. Now, infinite's a hard enough concept to define or even think about. But somebody was mentioning some research done in the last few years has led them to believe there may be multiple universes. What is that all about?
Yeah, no, that's a good question. So it's interesting. So both Marcelo and I are very hostile. Maybe not hostile is not the wrong word. But the idea of a multiverse, that there are perhaps infinite numbers of parallel universes. There's a couple different versions of this. Is an idea that there are a number of physicists, cosmologists who are willing to consider. There's not a shred of evidence, like nothing, for that. So I think it's a kind of fantasy in some sense. It's a great science fiction idea, and it makes for great, but there's just no evidence for it. And there's really, for me, it's more of a, it's a symptom of things that are wrong with physics theory than it is really, So it's possible. Let me put it that way. It's totally possible, and maybe someday somebody will find evidence of it. But right now, I think it makes more sense to think of the one universe. But again, as you point out, a very good point. That universe is probably, our universe is infinite. So when we did our calculation, we had to use the known universe, or not the known, the visible universe as our unit. But in some sense, you could say, well, why do that? Why not just include the whole universe? And then, of course, the probability becomes one. The probability that there's been others becomes one, essentially. So
Anybody else?
So if we're looking to preserve ourselves as a species, certainly we're looking to preserve the Holocene. But I wonder what your thoughts are about, maybe in the future we have some catastrophic event like an asteroid hitting us, or I guess eventually, the sun is going to die. So I'm just curious to know your thoughts about when we need to get off the Earth.
Yeah, no, that's a good point. So again, Leo, so this goes to the other point about, sort of you can only, I need to keep, in order to do, I really want these models to be truly scientific, right? They are models that have constraints on them that are imposed by physics and chemistry and maybe like basic Darwinian evolution. Going beyond that, I'm scared I'm just going so far into speculation that anything can happen. So, so what that also means is like, because when I thought about this, and sometimes I'm looking at what I'm doing, I'm like, wow, what would happen if we had 1 million years, right? Which is still nothing geologically, right? Who knows what we'd become, right? Like really, it's when you think about it, like 1 million years more of evolution of our civilization. Yeah, would we download ourselves into robots? Maybe, would we become post-biological? Would we become supra-biological? It's really stunning to consider what we might be on those timescales. And the only reason I raise that is because, by the time, statistically, the next really big asteroid should hit, that's already, far enough in the future that, like, yeah, who knows what we'd be. Hopefully, we'd be like not just a multi-planetary species, we'd be a multi-stellar species. We will have spread across the galaxy. So, it doesn't, I'm more worried about the next 100 years than if we make it through. But the interesting thing would be sitting here 1,000 years from now and somebody's freaking out about, some other problem. So if anybody watched The Expanse? Best TV show ever, I think, personally, But it's interesting because that takes place 200 years from now. And they, of course, the climate change is hitting Earth hard, but they have a whole other set of existential dilemmas. So I'm sure there's probably other existential dilemmas, in the future. But this one, what I like about this one is I just think there's just no way around it. Like the second law of thermodynamics just sort of almost forces you into everybody's going to create an Anthropocene. So, yeah.
Anybody else? So I have one. So if you look at the glaciation periods, they are sort of on a time scale of tens of thousands of years, roughly.
Right.
But complex life has existed here on Earth for about, at least the Cambrian explosion, but 500 million, really complex life, 250 million, which is 3 orders of magnitude bigger than that, which is good.
Right.
And the capacity that we have to modify the environment to build, things like this to protect us, may be a good thing. So that even if we do go through either overheating or freezing periods, that we'll be able to survive just because we're different from the other animals, which are just exposed to the environment.
Yeah, I think what I worry about, I think it's possible. That's why I think, look, there's going to be an Anthropocene. The question is not whether there's going to be an Anthropocene. It's whether or not it's going to be a good Anthropocene or a bad Anthropocene, right? So the bad Anthropocene is the idea that, if you push your planet too far out of the conditions that you came, that you arose, the complex networks that make a civilization, right? So civilization is their social networks that sit on top of the energy distribution networks, which are connected to transportation networks, which are connected to economic networks, and each of those individual networks have their own problems, have their own vulnerabilities. But what they found when you do network theory is that coupled networks are unbelievably vulnerable. Something that would not at all affect one of the networks, once it starts propagating through the coupling, can really mess with things. So my worry is that it wouldn't take much to really have our civilization be seriously damaged. Not that we're going to go extinct, but that this kind of thing may be hard.
We're going to Mad Max.
Yes.
Okay.
Or zombies, or because everybody loves zombies.
Okay, this should be our last question.
E.L. Wilson tried to take altruistic behavior in ants and apply it to humans and got a lot of political pushback.
Right.
Actually physically attacked.
I know, the pie in the face.
Right, and water dumped out,
Yeah.
It caused a lot of pushback. And here we are altruistically trying to do the right thing. And the words I hear from deniers are, what's this Gore saying? The planet has a fever. And we're trying to be altruistic here. And we know, I like that you've made it less political. Oil companies didn't start out as evil beings.
Right.
And whether we should divest from them is a difficult question. It's not automatically divest.
Right.
So I think we need to depoliticalize it. So I feel that what you're saying here needs to be broadened for people to understand that it's not purely, it's not just a visceral feeling on both sides.
Right.
I think it's a very positive thing to do, because E.O. Wilson, I think, was right in many ways. It doesn't apply to every single thing. We try to apply animals to us.
Yeah.
But will we always be here? You know, we're only part of the game.
Yeah. It's interesting that E.O. Wilson is now a hero to environmentalists and to, you know. But exactly, one of the, I think there's a real power in this perspective, because, you know, there's this political polarity that is about climate change. And this perspective just comes from here. You know, it's a completely, you know, if you're pro-business, you know, this message is like, human beings are awesome. Look what we did. We changed the whole planet, you know? I mean, it's a signal of our success, just like blue-green algae. It's a signal of our success, of what we could do, right? Of our power. So, you know, it has the, you know, but of course it's about what's, you know, don't make the next dumb, you know, don't be stupid about the next steps. So I think this perspective really depoliticizes, and it just takes it into a whole other domain, which is true, right? I mean, you know, it's true because there are all these other planets, but also it allows to completely recontextualize the discussion in ways that would sort of like, yeah, sort of cool everybody down. You know, the partisans are always going to be beating each other up, but this, you know, I think would allow a different kind of discussion that might bring, you know, allow people to come together. And
I hope so. I mean, humans come with an ego.
Yeah.
I think the last election, to me and many others, proved that having an oppositional finger really is not that important.
right,
You know?
right,
Okay.
right.
So I think we should thank Adam again for this wonderful presentation.